Well, hey there, kiddos. Here is video number 3. We're still writing equations of lines, except today we're going to write equations from a table. So now we've done equations from graphs, which was really very simple. Then we did equations with point-slope form. Then yesterday we did equations with 2 points, and now we're going to do equations from a table. This is going to feel very much like equations from 2 points because the process is going to be the same. Just how the problem is presented to you is what will be different. So let's get some practice in. First things first. You cannot write an equation of a line from a table if the data in that table is not linear. So the first thing we always need to check is to make sure that the data is linear, that it makes a straight line. And what is going to make it make a straight line is if the slope or the rate of change is consistent or identical all the way through the table. So the slope all the way through the table has to be the same. So the first thing you have to do is check and see if the slope is the same. So if you'll remember, when we have a table, to find the slope, we find the change in y over the change in x. And so that's all we're going to do. But we're going to do it all the way through the table and compare them to make sure that the rate of change or the slope is consistent. So if we look at this problem right here, my change in y from -2 to -3 is -1. And from -2 to 0 is 2. So my change in y over change in x is -1/2. So my slope right here is -1/2. So let's check these next 2 points. See if it's still consistent. From -3 to -4.5 is a change of -1.5. And from here to here is a change of 3. So that is a slope of -1.5 over 3. These don't look the same, but if I pull out my calculator and I divide this and I simplify it down, I will get that it reduces to -1/2, which is the same slope. So we're so far so good. This one, from -4.5 to -5 is a change of -0.5, and from 3 to 4 is a change of 1. So my slope here is -0.5 over 1. Well, again, this does not look like these two, but it will simplify. -0.5 is the same thing as -1/2, and -1/2 over 1 is just -1/2. So still, my slopes are the same. Check the last one just to be sure nothing tricky is going on. So from -5 to -7 is -2. From 4 to 8 is 4. And so my change is -2 over 4, which reduces to -1/2. All of my slopes, all the way through that table, simplify to the same thing, which says that yes, this data is going to be linear. It will be a straight line, which means I can write an equation of a line from this table. So let's check the next one, see if it is linear. My change in y over change in x from 11 to 2 is going to be a change of -9. And from -3 to 0 is a change of 3. So my slope is -9 over 3, which simplifies to just -3. So let's check this one. From 2 to 18, well, all of a sudden, something jinky is going on because from 11 to 2, my numbers decrease, but now from 2 to 18, my numbers increase. That should be a clue to you that it's probably not going to be linear, but let's check the slope anyway. From +2 to +18 is a change of 16, and from 0 to 4 is a change of 4, so I end up with a slope of 16 over 4, which is just 4. These two slopes are not the same. I don't even need to check the next two pairs of points because these two slopes aren't the same. Therefore, my data here cannot be linear. This will not make a straight line. If I plot these points on a graph, it won't be a straight line. It'll probably be a curvy, little wavy kind of thing. But it is definitely not a straight line because the slopes are not the same. So, let's practice writing some equations. For these next two, we are asked to write an equation in slope-intercept form, which if you remember is y equals mx plus b, for this function represented in the table. If you are asked to write an equation in slope-intercept form, it ought to be a hint to you that what you're dealing with is going to be a straight line, that it is already linear. You can't write something in slope-intercept form if it's not linear. So this should be a clue that these are going to be linear and you don't have to check, but we will just to be on the safe side. First things first, I have to know my slope. So I got to do my change in y over change in x. So from -13 to -10 is a change of 3, and from 5 to 10 is a change of 5. So my slope should be 3 over 5. Let's check here to be sure. From -10 to -7 is 3, and from 10 to 15 is 5, so it's still a slope of 3/5. So I'm good so far. I cannot go immediately to slope-intercept form because I only know the slope. I do not know what the y-intercept is, and nowhere in this table does it tell me. But like yesterday, I had 2 points, and I had to go plug them into that point slope form, into this formula that we've been using all week. So it has to go into this formula, the one that we've been using over and over, which means I've got to have a slope and a point. Well, if you look at my table, I have 1, 2, 3 points to pick from, and it doesn't matter which one you choose. I am going to use this one in the middle, but you can use any of the 3, and you should get the same equation. So let's plug in. I have to do y minus y1, so that's y minus negative 10, minus a negative becomes plus 10. My slope is 3/5. And then x minus x1 becomes x minus 10 because x is going to be 10. So distributive property, y plus 10 equals 3/5 x. That's this part. Then I have to do 3/5 times 10. So I'm going to have a minus sign here. Well, 3 times 10 is 30. And 30 divided by 5 is 6. To get to slope-intercept form, I want y by itself. So I'm going to subtract 10 on both sides. So I end up with y equals 3/5 x minus 16. That right there is going to be the equation of your line for that set of points. Now look at my next table. Let's do our change in y over change in x. My change in y, oh looky there, my y's are all the same. I don't have a change. It is 0, but my change in x is 1. So when I do my slope, change in y over change in x, I get 0 over 1. Well, I can do 0 divided by 1. It just equals 0. Well, my slope is 0. Since my slope is 0, that tells me that this is going to be a horizontal line. So this is one of my hoi. Okay? Horizontal lines have 0 slope. Their equations are y equals. Look at your table. Every single y equals 9. So the equation of this line is just y equals 9. That's it. Yes, I promise. It's that simple. That's one of those gimme questions. Okay, this last problem. Now we're going to be asked to write an equation in standard form, which if you remember looks like this. AX plus BY equals C, and A, B, and C have to be whole numbers, and A can't be negative. But they give me a data set. This isn't even written as a table. I just have 3 points. Well, so the first thing I'm going to do is make a table. This is X, this is Y. I'm going to put my points in the table. 2, 4... 6, 6, and 12, 9. There are my points. So step 1, I've got to know the slope. So let's find our slope. My change in y from 4 to 6 is 2, and my change in x from 2 to 6 is 4. So my slope is 2 over 4, which is 1/2. Just to be on the safe side, let's check here. From 6 to 9 is 3. From 6 to 12 is 6. 3 over 6 simplifies to 1/2. Yep, I have the same slopes, which means it's linear, so I'm good to go. I cannot, however, jump straight from the slope to standard form. I have got to start with this form and then manipulate it to make it look like standard form. So I've got to pick a point again. I have 3 points to choose from. Let's just use the top one and plug in the number. So I'm going to do y minus 4 equals 1/2 times x minus 2. I just plugged in my slope and my point. Distributive property, so y minus 4 equals 1/2 x, and then 1/2 of 2 is going to be 1, so it becomes minus 1. Now, if you want to go to standard form, the first thing I'm going to do is make it slope-intercept form, so I'm going to get y by itself, because then it makes it easier to get it into standard form to get all the x and y together. So I'm going to add 4 to both sides. So now I have y equals 1/2 x plus 3, because negative 1 plus 4 is 3. But I need my x and y on the same side because I want standard form. So I'm going to subtract 1/2 x from both sides of my equation. So now I have negative 1/2 x plus y equals 3. But I have big problems here. Number 1, I got a fraction. Can't have fractions in standard form. Number 2, this number in front of the x is negative. That can't happen either. So I got to clear my fraction, and so I'm going to take care of the fraction and the negative at the same time. To clear a fraction, you simply multiply by the denominator. So I'm going to multiply by 2 to get rid of this 2, but I'm also going to multiply by a negative 2, so the negative will also go away. So this leaves me right here with 1x. But I also have to do negative 2 times y, which becomes minus 2y. And then I have to do -2 times 3, which becomes -6. So in standard form, this is my equation that comes from that table. If I'd been asked for slope-intercept form, this would be slope-intercept form. I always start with point slope if I don't know the y-intercept, and then from point slope I go to slope-intercept, and then if I have to, I'll go to standard. But there's the order of things. Point slope, slope-intercept, standard if you have to. Okay, so like you hope you noticed, the process is very similar to what you did yesterday. It's very much the same. So now you have writing equations from tables. We will practice this tomorrow, and I will see you then.